So this is going to be the last video in the series. So let's just make a last few changes. One thing I noticed is this isn't giving me a lot of feedback. Right? Nothing. So I was thinking we could reuse the sound effects we've already made. This one we use for the menu select up and down, and this one to indicate we've selected an option. Okay. So, oh right, let me just run that again. Other quick thing, it starts with the shared controller selected. It makes most sense for the top entry to be the one that the cursor is on when it starts. So let's just make this menu item 0 to start, just so that that's there. And then sound effects, right. So sound effect 1 is going to be our menu up and down. So where I think it's in inputs menu. So inputs menu, if we press the up button, we play SFX1, and if we press the down button, SFX1, and then when we confirm with the confirm button, we trigger the menu item, it changes control scheme, we set the state, and then we play SFX3. And then for the keyboard as well, SFX3, save, run. Hey, that's good. That's the keyboard. This is the controller. What's also nice is now if I'm at the bottom of the list and I try to go down, I get the sound but nothing moves. Okay. Now, one last little update to the thing is for these paddles. Alright. I was thinking it would be awesome if your paddle moving could affect the trajectory of the ball a little bit, so that you can kind of play spin shots a little bit, make it less predictable. So we do know which way the paddle is moving, or we know which way the paddle was moving the last time it moved. The problem is we're not resetting that value at any point. You know what, let's just start coding and then the problem will present itself when relevant. Game updates. When the ball hits the paddle, at this point, oh, we go to pad hit. Okay, options, not options, or whatever the O thing, because O is the shortcut. I'm not sure why. Outline, that's why. Okay, in pad hit, boop, right at the bottom. At the moment, all we're doing is changing the direction, the X direction of the ball, just sending it back the way it came, keeping its Y direction the same. So we want to influence the Y direction of the game. And to do that, we want it to remain the same, but add something to it. Pad dot. We know which way the paddle moved the last time it moved. Problem. We don't have a paddle here anymore. But we can send it one. Pad. Because it depends which paddle. Up until now, just changing the direction of the ball, it doesn't matter where on the screen the ball is, we just make it go the other way. So if it's going left, we make it go right. If it's going right, we make it go left. But if it's going to be influenced by the current trajectory of the paddle, we need to know which paddle we're dealing with. So for pad hit, we add a pad. And then where we call pad hit, which is here, we need to send it whichever pad we're working with. We're still in the for loop, so pad refers to paddle 1 or paddle 2 that is in play. So where was that now? Here we go. Pad hit pad. Y direction is the current direction of the ball, and we add last move to it, because last move is 1 if it's going down, and -1 if it's going up. Let's run this. Now theoretically, if I go this way, hey, that's not bad. That's kind of cool. Oh. Doesn't help that I'm still terrible at the game, is it? Maybe it's having too much of an effect, though. Also, that's a problem. So, if this paddle has moved, I'm not currently moving, but it still changes the trajectory. Because last move is set and then never changed. So we need to know whether the paddle is currently moving or not. Now we can't just change last move to 0, because then if we're hands off on the controller, it's going to not launch the ball in the direction we're indicating and stuff. So we need to differentiate between launching the ball using whatever the last move was versus we have a last move value and we are actually still busy moving. That gives you the option to stop in place and just let it go back the way it came. So we only change the y direction if pad is moving, then int. But that means we need to set whether this pad is moving or not. So let's start with the pad itself, paddle itself. Last move is moving equals false. We can assume false because the paddle won't be moving when the game starts up. Same for paddle 2 equals false. And then we need to set this value. I'm just going to copy it so I don't have to worry about it. Where do we change last move? In input game. That's where we set last move. If I now go pad.is, well, I copied it, didn't I? Is moving is equal to true. Same for if we're going down, equals true. This is still never being set to false at any point. So here's what we do. When we start dealing with this paddle, we immediately set is moving to false. Then if this is false and this is false, is moving will never be set true again. It'll only be true during the particular frame that the paddle is moving. And because we have just updated last move, if both of these conditions are true, it means we have a direction and we are currently moving. Whereas for the launch thing at the beginning, during start, we only read last move, so it doesn't matter that we've stopped moving because we still want the ball to launch in whatever direction we were moving before. Is this the only place we need to change it? I think so. Check with the paddle to the screen. Yeah. So run this. Now, I don't know why I set up such a tricky shot for myself. Now, if I'm standing still, the ball would just be returned at whatever trajectory it was moving. But if I'm currently moving, hey, we can replicate the issue. Maybe that's a bit too predictable. Oh, wow. That got a bit extreme. So maybe in pad hit, maybe these values need to be kept in check a little bit. So let's only add a half times 0.5. So last move would be a 1. This makes it 0.5. And because it's being times by last move, if last move is negative, this will be a negative a half. If it's positive, it'll be positive a half, because we only ever set last move to 1 or minus 1. But then we also need to, because what can happen now, let's see if I can replicate this, is send it this way, then this way. See, this is getting a little, I mean, Maybe it's okay to leave it like this, but I can get this ball going crazy fast up and down. Maybe we should just limit that number a little bit. So it starts at 1, going up to 1.5, then to 2. That's probably a nice speed. So it can never go vertically faster than 2 because the horizontal speed is capped at 4. The vertical speed capped at 2, considering that the screen is lower than it is wide, wider than it is tall. So math dot, because we want the lower value of the 2, math dot min this and 2. That means the max speed is now clipped at. Oh, the problem is if it's going the other way, then it means I also have to wrap this in a math.max. The value that this outputs, or minus 2. Let's try that. Oh, it doesn't help if I make it slower, huh? Oh, I'm not good at my own game. I don't know if that's working. Let's just print to screen. Where's draw game? Draw game. At the end of draw game. Let's just print ball.dy so we can see what that value is. Thing is, I'm moving at 1.2, so as soon as my speed goes over 2, I physically cannot catch up to the ball. So either way, 2 is fine. So I can take this out. Maybe this is ugly. The number is buried in there. So let's quickly make a clamp function of essentially this calculation. Copy. Find somewhere to put it. Pad hit. Let's put it here. Function clamp. It receives a value, a minimum, and a maximum. And it'll return that math we just did. Math is a built-in class for Lua that has a bunch of math functions. It has like sine waves and max and min, and I think it might even have averages and stuff. It doesn't have a clamp function though, so we're writing one. And then instead of our calculation being in here, we just do this. Just leave it here so I don't accidentally delete it. We want this min-max combo for the max value and the min value, and we're returning it. Look at max val, min val, and max val, just so it doesn't look as confusing. Okay, so as long as we're passing, okay, and then over here to dy we are adding clamp, our little calculation, which now doesn't need brackets anymore, a value between minus 2 and 2. That looks a bit neater. Let's try it. That felt like it went up a lot really quickly. Let's just put the print the ball.dy. I'm just going to make it a bit brighter so it's easier to read. Okay. Yeah, that suddenly went up to 3. Something is buggy here. Let me see what I can do. Oh, you know what we need to do? We need to clamp the end result of ball.dy plus last move times a half. And then we don't need to put these brackets here because order operations, but it looks neater. This we don't need anymore. So that this is still behaving a little unexpectedly. Are we checking pad is moving? We are. But then min val, the min the max val. We need to pass this the value. You know what? Let's break this into 2 lines. Local lower equals math dot min between value and max val. So we want the lower of these 2, and then we can return math dot max between lower and min val. It's not as efficient, but it's easier to read. Take our value, lower becomes the lower of the 2, and then we return the higher of the 2. At least it's a little more clear. Okay, we can confirm it's capped at 2. And then lastly, a couple of cleanup things that you need to do if you're going to post this online. Firstly, there's a bunch of metadata at the top of the thing. Remember to fill this in. So title Pong, I just called it Pong. Author, your name, description, what the game is. If you have a site, otherwise just remove this entire line, including the, just like that. The license defaults to MIT, which means free use. Anyone can use it, anyone can adapt it. I am using the Creative Commons Attribution Non-Commercial license. That means that you can take this code, make your own thing with it, and put it online and share it with whomever, as long as you say where you got the original code, in other words, my code, attribute to the channel, and you don't sell it. Then I'm cool with it. Make sense? The same as on the GitHub. It's in the file as well. I'm not sure about the license, but the rest of this information, if you upload this to the TIC-80 website for other people to play, oh, you can do that. Create an account. Maybe I'll add a little insert at the end that demonstrates that. But if you upload this onto the TIC-80 account, it's going to need a thumbnail. And where that thumbnail comes from is the most recent screenshot that you've taken. Now, we haven't really taken a screenshot. So, this is probably fine. Unless, do we want a game in progress? This? Oh, my debug line is still there. It was in draw game. The bottom of draw game. This needs to come out. Okay. This is fine. Maybe just without the mouse in the screen. So to take a screenshot, you hit F7. If you're on a Mac and it defaults to your function row being your hotkeys, your media playback and brightness and so on, then you have to use the function button. But It'll say cover image saved. And then save. Either in here or type the word save. Run save. Save. Okay, now it has a thumbnail. Now let me quickly get to the TIC-80 website so that I can demonstrate the rest of this. Okay, so now you'll see the TIC-80 website running in the background here. On TIC-80, you type folder. It'll give you your folder, which we're looking at Pong 13, right? On TIC-80, you go up here to sign in. If you have a username, you type it in here. Otherwise, create an account. I'm just going to autofill my login. So you get logged in. Over here, you can set your avatar. I think you might actually have to draw it, but that's fine. And then down here is your games. So in your case, this will be blank. You just click down here, add cart. What are we adding? It's a game. Here you can put your text for your game. And then here where it says choose file, right? The easiest way to do it is to find your file and just drag it onto that button. There's the name of the file. And then you hit add to cart. Add cart. And that'll put it on. Okay, I'm just going to mark mine as a work in progress. Add cart. And there it is. Basically, that description was read out of the cart. It says who uploaded it, when it was added, the number of views. Someone else can download the cartridge. You can click to play and actually play it in the browser, which is also why it's handy to have keyboard controls. There's the text that I put in. And then people can leave comments, and the like thing on here is a little hearty tick computer. If you work on the file a little further, you can update cart and upload the new one to replace it. And as an added bonus, in TIC-80, there's a command called surf, which gives you this. Now these are your local files. Here's tic80.com. This is the stuff that's on the website. So if I, for instance, go to play, work in progress, new, there's our Pong. And there's our thumbnail in the background. If you hit Y on your controller, it'll go to the website for that we were just at. And if you just hit enter or the A button, it runs. So other people can now play your game. See? Works perfectly. And that is how you share your games with people. Also, this page that has the game on it, it has an address, a cart number. You can share this address to your friends on whatever thing you want, and they can just play it in the browser. You don't even have to install TIC-80 to play it. So you can share your game. So, I think that brings us to the end of this series. I'm already kind of half planning a next one. Don't know when I'm going to get started on that. It'll also be a classic game, kind of sticking to a theme. But if you come up with your own design implementations and ideas of our little Pong game, please share them with me, share them with your friends, experiment, make your own stuff, and have fun. The main thing is coding is supposed to be fun, so have fun.